Hey, what's up, guys? So let's solve this 2187 minimum time to complete trips. This is my last night solution. Probably not the best, but still solve the problem. So the problem is that you need to find okay. So just read it. Each bus make multiple trips successfully, and the next trip can immediately after each bus operate independently. And so basically, somebody gives you a total trip, and you need to return the minimum time that you can fulfill this trip. For example, this 3. The reason is that for 5, let's maybe draw something. Okay, so minimum time is 3. The reason is that for time 3, for the first bus, it will come 3 trip, and for second bus 1 trip, the third bus 1 trip. So total is 5 trip. And the computation is very easy, right? You 3 divided by 1, 3 divided by 2, 3 divided by 3, and then take the floor, you get 5. Okay. So this problem is actually ask the following mathematical question. So ask, find the minimum t. So let me just write find t, such that t divided by I, take the absolute value, the floor function, and from I belongs to time, is greater or equal to total trips. Okay, so this is your mathematical question, right? So you change this coding problem into pure mathematics. Okay, so your goal is to find the minimum t. Right? Obviously, if you choose t to be infinite, then this equation will hold, right? But you want to find a minimum t such that the t divided by I and take sum over all the I belongs time is greater or equal to total trips. Okay, but and you notice that this equation is monotone, right? This is a trick. This is the trick. So this equation is monotone. Okay, so monotone means that if ti greater than tf, then this equation, this left-hand side must be greater than the right-hand side. Okay, so it's monotone, so it tells me that you can use a binary search. Okay. So you can see the scale is n 10 to the 5. So if it's 10 to the 5, let's say this is n. If your algorithm run n squared time, you get 10 to the 10. This is so large, too large, right? So you can only run like n log n, and which in the binary search that you total got log n step. But in each subroutine that you will run the sum, right? So you get a length of the time. So it's times the length of the time, let's say. So this algorithm potentially run n log n, so have the potential to solve the problem. This is what am I thinking last night. Okay, so right, so let me just run through this part. Let's forget about this and then run this. So L equals to 1 and R. So you need to find the minimum, right? So the minimum time can be 1, okay? And the maximum time may be a total trip or the sum overall time. Okay, so this is a possible case. If L less than R, you calculate the mid, and you do the, and then you check whether mid has satisfied this problem, right? So start from s equals 0 for I in time, s at the mid I. So this is just this part. Okay, if this part greater less or equal to total trip, that means this part cannot be the answer. So L equals to mid plus 1, otherwise R equals to mid. Okay, but after this, you will find something very close. So you need to do some sanity check. You start from s equals 0 and R minus equal to 1. And so basically, you check whether if s still less than total trip, then R at 1, and then you just check it. So basically, this just sanity check that because there will be maybe some -1 difference. Okay, so this is just sanity check that you are, after this, you already narrow down your region. So it's narrow down your region. Okay, so in this narrow down region that you can try to, if you cannot, you start from R and you check whether R is the answer. If R is not, then you add 1. And I'm guaranteed that this part is very close to the answer. So this is just sanity check, right? You just keep going. Then you return R. Okay, but stupidly, this cannot solve the problem. Okay, because if you see this time limit exists, you can see that it blows up. It solves a lot of problems. The reason is that there are some input case, which is really stupid, that only one time and a very large total trip. So if you calculate this will give you TLE. Okay, so my solution is very stupid, right? If marginal case, so this is marginal case. So marginal case is that if you only have got one time, then the answer is stupid, right? Because if you only got one time, then this equation will be t divided by time. So your results just be total trip times the time 0. Okay, so this is very simple. And once you do this, then you can solve this problem. Once you add this marginal case, then you will solve the problem. Okay, not bad, but not the best way, right? But still solve this problem. Okay, and I think this is the optimal solution that you can take this binary search problem and go to this. And especially when you add this marginal case, will help you a lot. Okay, otherwise that you cannot find it, you cannot solve the problem. Okay, so see you guys next video.